Okay, for those joining us, we are doing a bit of Wolfram language design here. We are talking about error handling, and we have an elaborate set of proposals which I have not seen yet. And just let's take a look at the motivation and current problems. Okay, exceptions are widely used but completely non-standardized. Okay, that's interesting. But so what do you mean by an exception? You mean something that just stops execution dead in its tracks?
Essentially, something based on throw and catch.
Okay, but in confirming close is or is not thought of as an exception.
If you give it a tag, it is kind of an exception, but that's not really something we're promoting. So close and confirm are more similar to like optionals in some languages because you don't throw them across function boundaries.
I see. That so they're enclosed within. So the point of an exception is something went horribly wrong, and you're basically trying to exit to the top level. Is that correct?
Pretty much, yeah.
Yes, but I would like to point out that exceptions are not necessarily error conditions. I mean, there are things like a file, when a file ends, then you have a choice of either returning something and then dragging along that if statement, or you can generate an exception and handle it somewhere more appropriate. So it is a proper way of programming and not necessarily tied to something going wrong.
Okay.
To put it differently, exceptions are typically used whenever you need some non-local transfer of contraflow. And while it's not usually wise to use them in that capacity all the time, and usually it's associated with errors, but you can use them in a variety of other situations as well.
Robert, so what you're saying is enclose confirm is something which is essentially a functional programming construct that is in nested, essentially lexical, collections of functions. Whereas what you're interested in here is something that just sort of gets out of whatever complicated stack of code you might be in, and you don't have to, and there's nothing sort of lexically defined in there. Is that roughly right, or am I wrong?
Yeah, I mean, I think part of it is also that, I mean, in smaller pieces of code, well, right. I mean, basically, another way to think about it is it's a question of whether the errors are propagated by default or when you ask them to be. So with enclose and confirm, if a function returns an error, you have to explicitly wrap confirm around it again to propagate it to the next level. So you sort of have to ask for errors to be propagated, which is usually what you want. Well, I think it's what you want in small projects as well, and maybe even some larger ones. But if you have like really big projects and lots of very deep recursion, and you don't know, which functions are returning, could return failures and so on, then it's a lot safer for things to propagate errors by default, which is what exceptions kind of do.
Okay, fine. Okay, so should I?
Right. I mean, I had been intending to kind of do the walkthrough of this notebook.
But please, do you want to share and do it? Or
I'm all set up to share, yeah.
Okay, fine. Go for it.
Right. So, I mean, as you framed, I mean, the meeting, we're talking about error handling, and we're kind of talking about, I like to think about what we're talking about in kind of three different phases. So one thing we've been focusing on, I mean, let me open this up, is, I mean, some of the constraints we're working with are, we want to avoid kind of creating divergence between confirm and close type, failure propagation and exception type failure propagation. And one of the things I want to highlight is a lot of proposals that have gone on in the past about exceptions generally involve some kind of exception object. And we've tried to focus a bit more narrowly on what are the kind of minimal improvements we can make to an existing form like failure to accomplish a lot of the same goals that we have without adding a new form to the system. And in particular, we don't want things that are not specific to the way that the error is propagated to be present in kind of the design. So basically, whether the error is thrown or whether it is returned or whether it is propagated using confirm and close shouldn't really change what's in the error or what's in the failure. So obviously we're going to talk a bit about failure itself and some things we want to do to hopefully make improvements to failure. And then we're going to talk a bit about improvements to exceptions in general. So, like I said, there's kind of phases for this. First is improvements specifically to failure. These would be things that have nothing to do with exceptions and would be general improvements for projects with, that are not using exceptions or for projects that are using exceptions. So a basic one is building up infrastructure for making stack traces a bit easier to capture and a bit easier to display and a bit easier to kind of compute with. Now, Leonid will have, I think he may have an example of this later, but I'm just going to kind of give an illustrative overview of this. So a simple thing would be is we want to add a stack trace field as a convention to failure objects. So obviously failure objects can contain any kind of metadata. We want to define a form that could be kind of the conventional thing that goes in that stack trace field. This is kind of a side point, but we want to do some changes to the formatting of failure because it's not ideal in all circumstances, especially when you have larger, richer failures. Then the other thing we want to do is kind of improve the tagging of failures. Right now, if you look at the documentation for failure, the tag of a failure, the thing that gives it its identity, is basically just a string. And for a number of reasons, we want to kind of make that form a little bit more general. One specific reason is that, as I mentioned up here, a lot of projects have their own raise and catch functions. And one of the underlying structural reasons for that is that we have throw and catch, and we have a 2-argument form of throw and catch. And the 2-argument form of throw and catch has this tag argument. You can actually have a look at that. Do this down here. So 2-argument form of throw has a tag, and 2-argument form of catch has a tag. And these are meant to kind of scope, or as a pattern, sorry, that matches a set of tags. And these are meant to provide some level of scoping to the thing that gets thrown. And a common convention, and one of the reasons that these paired functions pop up in a lot of internal projects, is that people want to make that tag some unique key that's specific to their project, so they can be confident that the exceptions they're throwing are only getting caught by their own code. And we want to add a similar ability to filter for failures that are generated by a given code base. I mean, the thing about the 2-argument form of throw and catch is that it's integral to how that error is interpreted, but it's not directly computable. It's not part of the thing that's thrown, which makes our exceptions a little bit different than exceptions you find in a lot of other languages. And it also makes it a bit harder to kind of programmatically decide based on the content of the thing that is thrown, whether you want to catch it in one location or another. So concretely, what we want to do is add support for using symbols as tags, and potentially using kind of collections of symbols, a list of symbols. And I'll talk a little bit more in phase 2 about that. But that's the basic idea, is we want to make that tag field richer so we can have richer identity for failures. And one of the functions we're talking about adding maybe to support stack traces and tags is a new create failure function, which would automatically add in that stack trace field based on some kind of global configuration. And one reason to do that is that if you have a large project, where you're creating failures all over the place, most of the time you don't want those fields to those failures to include stack traces, because stack traces are kind of a thing that the programmer might want to look at. But as a user of a piece of functionality, if you get a stack trace with a whole bunch of internal function names, that's hopeless. That doesn't really help you figure out what went wrong. But we want to make it possible for people to write code that uses failures in a way that they can later, in specific situations, opt into having those failures include stack traces. So we're thinking about something like a $capture backtraces, system level variable as an example, that would change the behavior of create failure to either include or not include that stack trace field automatically. And obviously that behavior would be overridable with a local option.
Usually a create function is creating some kind of global thing that is, in some global table, but this is not what this is doing. This is making a specifically templated form of failure object. Is that correct?
That's correct, and the name might not be be perfect.
Probably make failure or something like that would be a better name, but
yeah, I think I started with make failure and then create. Yeah, anyway.
All right. Okay.
I mean, we do have things like create data structure and create compiler environment, but yeah.
Well, okay, whatever. Let's not solve that problem right now.
Yeah, but we want to form a function of this form that does the conditional stack trace, addition, and also does some additional operations on that tag that we talked about. So
hold on a second. I mean, so a failure object failure does not usually evaluate. Usually, it just sits there as a inert symbolic thing.
Yeah.
You mean the constructor for failure? Yeah.
Yes. So you're proposing that at construction time, that it might have pieces that it captures at construction time.
Adds, not captures, but yeah, it would be something the constructor could have additional logic, like whether to add this stack trace field or not.
Okay, fine. But I mean, the basic point is, in this block of code, for example, or maybe globally, but I think it'd be better in a block of code that all failure objects, because I can imagine a situation where most of the time you don't want it to capture the stack trace and just generally make a big mess. But if you're in a debugging mode, you do want that to happen.
Exactly.
We could have $, stack traces or something equals true.
Yeah, or we could just have a function, a wrapper that says, stack traceify and then some big block of code, and that would do the same thing. I mean, it would be a similarly dynamic set thing, which then would cause all the failure objects that are created in that, because to me, it seems like it's more a question of what is the runtime environment than what is, one block of code wants to have stack traces, another block of code doesn't. It's more, I'm either running it in a mode where I want that stuff, or I'm running it in a mode where I don't want that stuff, seems to me.
Yeah. So that's exactly correct. Yeah. I mean, this was not meant to be something you hard code into your project, but something you'd put at the top level when you, the programmer, are trying to debug it.
Right. So capture stack traces as a wrapper seems like a nice idea. And then every failure object could.
I could certainly see, uses where inside your project you always want to capture the stack trace because you're going to handle that and return something nicer to the user.
Yeah.
I mean,
a simple
that may
example,
not be what you always do, but that's certainly something you might want to do.
Yeah.
We could even imagine the users may want to do that if they want to submit some bug report with a stack trace, which might simplify work on our side.
Right.
Yes, but my point is that once this thing is in capture stack trace mode, every failure object created doesn't need a separate create failure wrapper. It just every
no. This has to be a wrapper function.
Why?
We need other. We'll explain below. There are other reasons to have it.
Okay, all right, fine. I'm not convinced yet, but just okay. I get the point. There is a way of getting inside a failure object. There is a standardized collection of things one might add, like stack traces.
Yeah. Now, the other thing that we've been talking about doing in this create failure and why we need a function as opposed to, just using failure, is this concept of tag expansion. So the first step in adding richer identity to failures is supporting symbols, not just strings in that failure tag. The second step, and this is something that comes into play in larger projects where you have kind of more complicated relationships between errors, is that you want kind of a light subclassing mechanism to be able to say that one type of error is kind of is one element of a class of errors. And a simple example in this illustrative examples notebook is a file not found error is also a file error and an IO error. And this is slightly pseudocode, but this is roughly what this might look like. Is if you do create failure of this thing, you get a failure out that kind of says what the primary error is, but then also says what the other classes of error that this thing fits into are. And this is the reason you want this is that you often have, again, in larger projects, a lot more, some kind of outer handler, at the top level of your code where the exception reaches up to the, whatever your public function is, you have some big thing that handles all the failures that your code can produce. And so you want to kind of match over what each kind of failure that came out of your code was. And
okay,
we want to handle.
Yeah. Mm-hmm. Right. So, I mean, look, just to make a general comment about all of this, okay? I think one way to think about this is, people write code intending it to follow a particular path where most of the time it will, do what they think it will do. But sometimes it doesn't. And sometimes it hits a guardrail and, spins out of control. And I think one of the issues is there a way to basically bucket the ways that it might spin out of control so that they can be bulk handled, because we're not going to handle every single code path of every single different way, or you don't want to have to. You want to be able to automate handling a whole collection of different ways it could spin out of control.
And that's exactly what this system is supposed to do, Stephen, that we are discussing.
Right. And so one of the things we've talked about, and I like this comment from Connor about this point about intersecting tagging, because one of the issues is, we've tried this even from version 1 of kind of identifying from our messages, for example, what kind of, is this message a critical failure, or is it, oh, you could ignore it failure? The numerics failed to converge error is not a critical error if you're just trying to lay out some graphic. It is a critical error if you're trying to, launch some spacecraft or something, right? So
yeah,
one person's, depending on the use case, and it is the case that there are plenty of exploratory analysis cases where even getting out, you've got 1,000 pieces of data you're going to get out and 7 of them have failures in them. You still want the other ones to come out. You don't want it to say, oh, there's ones that are failures, I'm going to shut everything down.
Yeah. And to make that concrete, I mean, I have these examples. These are slightly pseudocode again, but the idea is that in this phase 2 section, we're actually talking about improvements to exceptions themselves. We have this concept of a handle function. Now, this is analogous to catch, but it differs in some fundamental ways. The basic idea is that it allows you to sort of match over the failures that get thrown.
Yes.
So this is how you would actually implement, handling a file not found error, differently from a general IO error. And this is how you would implement what you were talking about, where you might have, something that I didn't expect happened, but it's a class of the very generic IO error type. So I can print some generic thing saying that, hey, an IO error occurred. And if you want to, we have this kind of concept of I
so hate, thing. Most people who use software, when they see the thing unknown error occurred, they're like, what the heck happened here? It's anyway, that's a horrible wimp out.
Right. Well, sometimes it's the best you can do if you're not.
Well, I understand that, but perfect. So my question would be, of all the messages, and I don't know how many thousands there are that are associated with built-in functions right now, are you imagining that we bucket those messages to be to have tags that are effectively like, that map into this error system?
So there isn't currently any specific proposal like to turn messages directly into tags. One of the places that this handle function came out of, and Roman is kind of the originator of this handle design that we've kind of retrofitted it to this proposal, is that it kind of serves as a combination of like check and catch and check abort, and that you could do, you could do something like, I'm going to kind of make this up, but you could do something like to catch messages or to handle messages with this form. And that might be a way that we have a single construct that can handle every type of thing that can go wrong in the system in one unified.
Yeah, I understand. But the problem is one of the issues is you're doing your rocket launch. You want to make sure there's nothing, no message generated that was a numerics fail to converge, whatever else. You're doing your user interface layout. You want to make sure that there are going to be no pink boxes, right? Different kinds of things that you want to make sure of. And that was one of the original issues here, was sort of making buckets of those types of things.
But it's also not just buckets, it's a hierarchy, which I think is also useful. I mean, one of the other reasons why the hierarchy aspect I think is very important is that I think that, the solution to the problem with throw and catch again is that you need to have project specific tags in order for, there not to be cross package catches and throws that interact with each other. And so part of the solution here is that, you can have, it wouldn't be hard to sort of introduce basically an error class, which is a lot like a tag for your specific project. But it's sort of, it's much more ergonomical to have, it's much more, with this interface, it's much nicer to do that than it is to do with throw and catch right now.
And regarding the point about classifying messages, I mean, I spec this out kind of on a whim, but we could imagine having something like, I was thinking like a logic error type, superclass. So if you have a failure in your code that represents, like I said, something that you, the programmer, didn't anticipate occurred. So it's kind of a fatal error. If that happens during your rocket launch, something is terribly wrong. And you might have at the very outer edges of your code, you might have a handler for these kind of very high level error types, where you just want to bail and give up as quickly as possible, because if this happens, you're really in unknown territory. And we could imagine something like classifying built-in messages into things like these classes. Though I think the problem is, and the problem that I think previous efforts to classify these messages have failed, is that it's very context dependent often, why a message gets generated and what that actually means. So it's not easy to make a definitive mapping of something like general argc to a specific error tag.
Right. But maybe the trick is just to give the tags or these error classes, to give them less presumptuous names.
Yeah.
But there is also this problem that Connor mentioned, indeed, because most of the time people in this specific project will introduce their own custom error types, and so it will be them who will be deciding which to which more general classes these specific errors belong. While here, if we try to classify messages uniformly, then we are kind of trying to make all decisions for all the kind of different situations for people, and that's where the problem really lies.
There's also, of course, the question of how much effort we should put into maintaining our error messages, or whether we shouldn't gradually move from error messages to failure objects wherever we can, because
no, we don't want to do that. We don't want to do that. There are plenty of error messages that are just side commentary. We don't want to return a failure object whenever the numerical scheme is not converging as quickly as we thought. We don't want to return a failure object.
Yeah,
ever.
But, I mean, there are, at the moment, there are still a lot of cases where things return unevaluated, and that unevaluated thing then just explodes in all of the
that's code. Correct. That's okay. Look, there are cases where it returns unevaluated, where there are serious possibilities that people might overwrite the unevaluated thing and want to do something with it. There are other cases where it returns unevaluated only because 35 years ago, that was the best convention we could, that was, we had the idea that more people would redefine those things, like, the inverse of a, let's say the inverse of a singular matrix, okay, that returns unevaluated. Now, we could return a failure object, but I don't think that would be the right thing to do in that case. I think.
Yeah, but I'm thinking more of things like wrong number of arguments, right? I mean, there's absolutely nothing you can do with that.
That's not correct. That's just not correct. I mean,
well, I think there's also things like Nettrain. I think it's less about the how incorrect your usage is, and it's more about the domain. I mean, if you're doing sort of symbolic mathy stuff, then it's very common you have unevaluated things. But if you're doing Nettrain, there's really no world in which an unevaluated, a Nettrain is ever going to end up evaluating successfully.
Yeah. Right.
And this is a general problem we have, where that in a lot of places where the semantics requires some more aggressive error handling, we still have to rely on messages, And the real problem with there are a few problems with messages which make them as an error handling mechanism pretty poor compared to exceptions. And that's why I think Roman mentioned this problem, that in those places where exceptions or other more aggressive error handling methods are more suitable, we really would like to switch to those.
Well, I understand that, but you also, this is why I mentioned this point about, for a rocket launch, you want the numerics error to be fatal, right? For a layout on the screen, you just don't care.
Right. Well, the obvious solution is just if you wanted to have some transition thing. I mean, if we're forgetting about backwards compatibility and stuff like that, right? Then what you'd want is it so things still throw messages, but they also raise exceptions. And if you don't handle the exceptions, then nothing happens. Like it just runs like normal. But if you do ask to catch them, then it'll stop.
I think that's sensible. Yes, I think that's a decent idea. I mean, I think that yes, that's a reasonable idea, that we use the fact that we've got thousands of messages in the system which indicate various kinds of error conditions. The challenge, and we've tried to do this, we tried to do it, there's even code that tries to do this in the messages system, that tries to bucket messages. For example, we have the off mechanism that's from 35 years ago for switching off messages. And it has a way of bank switching off messages, or it tried to have such a way. It was much harder to classify those messages than one might have thought. But I do like the idea of a multi-tagged, I think we already had that idea actually, like decades ago, of being able to put a given message into multiple tag bins.
You mean message groups?
Yes, that's what I mean. Is that what? Yeah.
Right. So certainly message groups need not be disjoint, right? Right, and they were created for V6 and then they were never updated.
Imagine, again, not how you really write this, but something you want to handle with graphics type message differently. I like that idea, though, Christopher, about having a kind of, maybe you could think of it as like a default handler that if it doesn't get handled, execution resumes where it was thrown. That would certainly be unique, I think, to Wolfram language, but it's a nice idea. I mean, you could imagine something like, in the handler definition at like the outer level, for a message, you could like return the symbol continue. I mean, this is maybe weird, but something that would indicate like, we want to make this programmable. So this isn't like in, special behavior. People could work with this. And if the handler says continue, then execution just picks up where it left off down deep in the code. And you could kind of decide on a per message and per context basis what you want to do.
Is that implementable?
Yeah, I don't think that's implementable. How would you implement something like that?
You would need continuation support for that.
Yeah.
Well, presumably the evaluator, I mean, it knows about, I mean, I find maybe it's harder than I think, but like in compiled languages, right? Like the implementation of the stack trace mechanism, like lib unwind, which is kind of the standard for this, you register handlers for kind of exception tags, and you can kind of indicate, there's a kind of a really low level way of indicating, basically you return a bit flag saying what you want to do with that exception, whether a specific handler handles it. I don't know if the kernel uses something like that, but you could imagine, the handle function would register a set of handlers. And at the point that one of these special messages is issued, it would check the set of registered handlers and see, is there a handler for this type of thing? If so, run it, see what it returns. If it doesn't return something that says, if it returns kind of normally, then control flow picks up, in the statement after the handle. If it returns the special symbol that indicates continue where the message was generated, then the kernel would just keep going where it started. It wouldn't actually unwind the stack until it ran the handler.
Okay. Well,
Maybe,
okay.
Okay. Well, I think we would need, people like Tom and Mark to opine on something like that.
Okay, let's keep going here.
Yeah.
So,
right. So we got slightly off track. It's an interesting idea that we should explore that in future discussions. Right. So we were talking about create failure, and we did kind of get into raise and handle, which is the next thing I was going to talk about. I mean, again, raise is analogous to throw. Its argument structure, and I'm just going to skip ahead. Its argument structure is very similar to create failure. Really, the only difference is that create failure doesn't throw an exception and raise does. So they take virtually identical argument structures. And that's really all there is to say about raise. Handle is where things get complicated. But I do want to talk a bit more specifically about this tag expansion idea and what that actually looks like. So the basic idea that we have at the moment about how that would work is that we have an additional new symbol, a new function called create error type, something like that, or register error type maybe. And with that, you pass in the name of the error type you're registering as a symbol, and you pass in a list of super error types, essentially, the sets of error types that your sub error type fits into. And additionally, there's a 3-argument form that kind of lets you register a validator function, something that gets applied to any failure object that is created with this tag. And that gives you a little bit of more control over ensuring that a failure of a specific tag actually has a specific form. And so you want to be able to validate that if you handle this error at a higher level, it's always going to have, for example, the file path metadata key, so that you can produce that in a message or something and format with it, something like that. So that's how you register a new tag. Then there's this concept of tag expansion, where these things actually get kind of blown up into this form that you see in the resulting failure. Because when you, I'm gonna skip this list for now, we'll get back to that. But when you call create failure, right, with a specific tag, the thing you get out might be something like this. So if we were to evaluate this create error type up here that says my error is a subtype of IO error, and then we were to call
this idea of using things as symbols or as heads. But anyway, never mind. That's a detail.
Yeah, I mean, it's a detail. But the basic idea is you call create failure with the specific error type. It fills in something that looks like this. I mean, this is the alternative form. I'm slightly partial to this form where it's just a list. And it fills in the super type, and then there's this kind of general error super type that everything is a subclass of, but that's also kind of a detail. And you get out, if you do all this, you get out a failure that has, well, okay, this is actually, ignore that. But this is the idea. This is what you get out. And one of the things that I want to point out here, this may be obvious, but we're trying to avoid encoding any kind of state about the hierarchy of error types statically. Like, this failure object has all the information you need to know about how to identify this failure. There is no implicit global state about that my error is a subtype of IO error. You just can see that from what's in the failure itself, because these create error type calls are building up some big global state in the kernel of how a bunch of different failure types relate to each other. And that's fine when kind of your code is running, but if your program ends and or the kernel quits or whatever, you want the failure you get out to be this stateless thing. So that's why we do this tag expansion eagerly at the time the failure is created, rather than just depending on that global state to always exist. So that's the basic idea with create failure.
Well, okay, hold on. I mean, well, okay, yeah. Maybe you should show me the whole picture, and then let's come back into
well, we're actually getting pretty close to the end. I mean, there are a lot of unresolved questions with handle, because it's a much, well, I mean, as you can see here, there's a lot of ideas about what it could do. And we could talk a little bit about that, but really, I mean, I mentioned what raise is, I mentioned what create failure is.
Hold on. Go through raise again for a second here.
Sure. Okay.
I mean, create failure is basically creating an enhanced version of a symbolic failure object.
Yeah.
Okay.
Yeah.
Raise is create failure plus throw it with possibly additional stuff. But right, it automates the throwing it in a way that's sort of maximally useful. At least that's the idea. Whether that's actually true, I suppose, can be debated.
Right.
Although
so this is then okay. So we've got confirm and close. We've got throw catch. We've got raise handle. These are all different levels of kind of heavyweightness of non-locally transferring control.
I don't think it's so much heavyweightness, but sort of like low level versus high level. Like throw and ultimately raise and handle are just calling throw and catch. They're just
right. But throw and catch are low level operations.
Right.
Yeah, and crucially, they have no defined structure. Raise gives us some amount of dependability that the thing that comes out is of a particular form.
Right. Well, yes, right. So raise, yes, the thing that is thrown will be some kind of failure object.
Yes, and it will be self-contained. That's the biggest issue we are trying to solve, and that's why the standard throw and catch are not very convenient in that, because the identity.
Yeah, they're just showing free-form things, right? So you don't know what you get.
Yeah, and not only that, but also the identity of the thrown thing, it lives elsewhere in the tag, which is a second argument. While here, the identity lives inside the failure object.
Yeah, I understand, which is good. Okay, understand. I mean, so the basic point here, yeah, okay, I get it.
And also this hierarchy of tags that we are creating allows you to selectively catch errors of different generality. And actually, I don't know if we come to those examples that I have in a kind of runnable form. I have an example there where how you can make a hierarchy which allows you to easily catch, for instance, all the errors within your package, while they may have internally different subtypes.
Okay, so you're saying that raise produces this error, but the choice of whether to handle it, the handler could pass through a raised error without handling it if the tags don't match in some way.
Exactly. That's the whole point of all this, because
okay.
Yeah.
And then at the top level, if the thing ends up at the level of the REPL unhandled, then what will happen?
That's a very big question, and that's something we wanted to discuss in the phase 3. Maybe Connor can also discuss that now, because that's a little bit going ahead, but it's a very important topic.
Yeah.
It probably depends on what the actual thing that's running it is. I mean, if it's running it inside Wolfram script or something, and it's intending to be some function that does something, you probably want it to, just fail and exit out. Whereas if you are in some kind of notebook REPL, you definitely don't want it to quit the kernel just because some particular exception was unhandled.
I mean, currently we have examples of different behavior. I mean, if you have an uncaught throw, then you get some pretty nasty error message. But if there is an abort inside your program that is not handled, which is the normal case, then it just returns $aborted. So that top level handler should have a little bit of intelligence inside it to decide, maybe with the help of some tags inside the failure object, whether it is okay to be unhandled or not. Or maybe just turn the thrown failure into a failure object that is returned.
Yeah.
Yeah. Well, but I think what should happen is that the overall, when you set up your kernel in the front end, or when you are running it from WSTP server, or when you're running it in Wolfram script, probably one of the options there should be what to do if there's an uncaught exception, because you want different things to happen in different cases.
Yeah, I mean, that is also very true. I mean, that's something I've always struggled with parallel kernels, because there is something at the top level of that subkernel, but that thing should, in one form or another, make it back to the master kernel and trigger some appropriate action there. And so at the moment, there is no good way of kind of handling all that could go wrong in the subkernels, and in the future there will be, and then it will be much easier to have a clean way of, for example, writing a function that evaluates an expression and guarantees that whatever happens inside, including quit or whatever, it will return with the result of that evaluation or an indication of whether there was an error thrown, but it will not escape.
Yeah, well, right. Sometimes you want. Go ahead.
But yeah, but there is yet another case which is completely opposite and also very valuable, because right now our public functions are explicitly not allowed to throw exceptions to the top level except throw itself. And in some sense, exceptions become much more useful when you allow them to propagate through the package boundaries. So that's one of the core kind of questions we really want to decide, whether we in some form, because it may look on the front end in a pretty nice, but whether we allow to, in some cases, propagate exceptions to propagate to the top level or cross the package boundaries, because that would make them that much more useful.
You mean to have them encapsulated within a package, or to have them able to escape?
As an example, like in some cases, it may be that, let's say you are building some functionality on top of some middleware, and then middleware A sends an exception, and then their next layer is middleware B, which doesn't know how to handle that exception. It would be good if that middleware B would be allowed to just pass it through.
Yeah.
In that case.
Yeah. Right.
Well, of course, but that also means that, if you directly call a function which, doesn't, right, if you map some package function which is in the habit of, throwing an exception that it doesn't handle, then, and you trigger that exception in your map, then you've lost everything in your map, right? Because once that's triggered, it completely aborts the computation.
Yes, but that's a responsibility of the user of the map, essentially. But I agree, it's a tricky question. If you take some functions as arguments, and those functions are throwing exceptions, that's one of the tricky points where really we need to decide what happens. But that's one of the complications of allowing exceptions to propagate. Yes.
So I didn't understand that. I'm sorry. Could you go through that again?
So suppose you create some package function, my wonderful function, and my wonderful function can throw an exception. Now, if you, map it across like range of 1,000. Right. And, and 999 generates an exception, then you get nothing out of your map, because
what do you mean you get nothing out? I see, because then it does it, in particular, it runs raise, and raise,
right,
like throw, just sends out this failure object.
Right.
But in fact, the outer handler says, I don't care about that failure object. I'd be fine with you just, treating it as a pink box or something. Right? That's the case you're talking about. So you're talking about inside the inner function, there was a thing. I mean, so one way to handle that would be, since there is execution that starts off with the handle is called first because it's the outermost thing. Well, maybe it isn't. I don't know. No, handle presumably doesn't.
There's no handle here, or if there is a handle, the handle decided to resolve this issue by just doing another raise. So the exception is propagating outside of my wonderful function. That's what Leonid is talking about.
No, I understand that. But what you're saying is, at the very outermost level, the handler, it propagates all the way out to the REPL handler. And the REPL handler says, oh, actually, I don't care about that error. But it's too late because the thing already exited the map.
Exactly.
Yeah.
Then you have to wrap handle around each call, or the question then is, if that exception is fatal, then is it really okay to have to get something
hold on. There's a different way to handle this. Okay, just as you had a $stack trace capturing thing at the outer level, which was a dynamic variable that seeped into all of the innards of that computation. So in principle, the outer handle, if it was a held function, and an outermost evaluation function, that could set, the outer handle that says I don't care, could set some state that basically says, okay, if you've got some inner ray.
I'm not sure what is this outer handle you're talking about. I mean, that is the complete input I'm talking about. What Connor wrote there.
I mean, and to frame this, I mean, imagine that my wonderful function is like takes 5 minutes for each element, you know, and so you really don't want to lose your results.
No, I
if one of
understand
them
that,
fails.
but sometimes you do. In the rocket launch case, you do want to lose everything.
Yeah.
You prefer to. Okay. So what I'm saying is the decision of whether you lose everything or not is taken by the outermost handler, the handler at the REPL level, right? Or whatever the outermost handler is. And so what I'm saying is, if you define that outermost handle to, to be evaluated first before it goes into its innards, so that effectively $pre at the level of the REPL has a handle in it, and that handle says what things to care about and what things not to care about, then by the time you're inside that map, the thing that does the create failure knows, oh, I'm in an environment where nobody cares about these kinds of errors. Let me not raise that error.
Still, there is a problem with this approach because it is very general and it works on all code inside. So in many cases, when you try doing that, what ends up happening is that there are multiple decisions that programmers make inside the code, and they may not always anticipate that the global environment has changed. So in practice, usually it's safer to have local wrappers, like what Connor was showing, but he then deleted that input. Something like suppress at. But the problem with this, of course, is that it's an inconvenience for the user. They will have to.
But
think
I'm
about
sorry,
that.
I don't quite understand. The issue is, at any given level, you could say this subsystem is one where, so in other words, the innermost handle is what determines whether a particular raise is going to produce a get out of here response or not.
Yes, but the question is where that innermost handle has to be.
Well, I assume it's in the evaluation chain. I mean, if, as opposed to it being lexical, it's something which in the evaluation chain that gets down to that final map. Somewhere there is a handle that you get what I'm saying?
Yes, yes, I do. I'm just saying that in many cases, because imagine that you have code which has like 10 function calls inside the handle. And in some of them, we may want not to throw, but in some others, we may actually want to throw.
But how do you define that? How do you describe that? And what I would have thought you do is you say, this is a handle in which I don't care about class of errors A, B, and C, but I do care about class of errors X and Y.
Yes, but you may inside have function calls in part of which you really kind of don't care and allow things to be thrown, or in others you actually don't, and they may be the same kind of errors. So my point is, having a wrapper type handler around some piece of code might in many cases be sort of too wholesale to really address specific code situations.
Look. The problem with this is the following. As I was saying in the preamble here, the problem is this is automatic coding, basically. We're trying to not have the programmer have to trace through every error case and say what to do. We're trying to automate that to some extent. It will not be perfect. But what I'm saying is, and I didn't understand your comment, if they have more detailed treatment and they can figure out, yes, I know that the 200 kinds of errors I could get, I'm going to handle every single one of them in a precise way. We need to give them the opportunity to do that. But most of the time, they won't bother. And most of the time, this is essentially an automatic programming that will do better than doing nothing, but won't necessarily nail every error case. So, I mean, what am I trying to say? I don't understand what's wrong with the thing I was proposing. That is that you have a series of handles that are passed through, which each dynamically set the state of the current, sort of handling structure. And so, for example, one handler could say, okay, pass, I don't care about this type. I mean, it's slightly complicated because you're switching on and off things that you care about. And I don't know exactly how that works. And that doesn't seem trivial to do. There's a who gets to decide for sure. Like an inner handler could say, this is a really important message. This is a really important error. I want this error to go all the way out to the REPL. But the thing at some level further out towards the REPL will say, hey, wait a minute, I don't care about those kinds of messages. See what I'm saying? So who wins in that case?
Yeah, that's exactly the problem. Because I think that in most cases, the one who should decide whether to propagate an error or not, at least initially, is the one who writes that particular piece of code where the error is getting propagated. And if we try to second guess that from global wrappers, we may be good in some cases.
I want to jump in with a much more general comment. I mean, the really zoomed out picture of what we're doing here is like the high level problem is right now, it's not as easy as we would like for people who are interested in writing very robust production grade code to do that in a consistent way, right? And I think it's important to recognize that when we're talking about error handling, we're talking about one of these extremely fundamental pieces of infrastructure to people who are interested in writing robust code. And I think it's conceivable that we could imagine a more, a mechanism like you were describing, Stephen, that kind of injects computation at multiple levels and allows very fine-grained control of what happens. But the context is we're talking about something that needs to be incredibly reliable, so that people who are interested in writing something reliable can do that.
Look, my claim would be there is a version of this where everything is on a hair trigger. Anything goes wrong, it just exits. Okay? That's your case for critical code.
Yeah.
But I'm claiming that there are many, many, many gradations of that go down to, this is just exploratory code. I don't want the thing to blow up the memory of my computer if it goes in that corner. Let me protect that. But I don't really care if there are a few pink boxes on the screen from time to time. Okay? I think there's I think your hair trigger case is an important case to cover, but it is not the only case. And it will be super annoying. But, even in development, people are they're not going to want the hair trigger case because it's going to be too much of like, wait a minute. It's like, okay, you're writing a C program, for example, okay? And the thing, well, okay, this is a bad example perhaps, but, and you say, I want to see what this is doing. And every time you run it, it just crashes, right? And it doesn't get anywhere, it just crashes. It'd be much better. And then
that's the good case as far as I'm concerned, because it means I can just
go to
stick it in the debugger and look at the backtrace.
Yeah, I know. So that's why I was saying this isn't such a good example. But one could argue that it would be better to have the thing limp all the way out. I mean, there are plenty of times when I'm debugging things where having it limp all the way out and, 5 of the values are correct, and then the values 6 through 9 are wrong, okay? Or and have a full of symbolic crud and error messages and so on. That's a common form of debugging. Is some stuff works, other stuff doesn't. You go and look at the stuff that doesn't work, and you don't want it to hair trigger and go and just say, "Oh, it's all bad," type thing. So I mean, I really do think both cases have to be supported. You are right that for certain kinds of production code, which that you just want the thing to hair trigger and blow up. But
so
yeah, go ahead.
Maybe helpful to make this concrete in what we actually think a specific piece of code could do. So in this example that was described, I mean, I think what you're describing, and make sure I understand this, is there's some implicit thing that's based on the fact that I'm in a notebook that kind of sets up a handler that causes an exception within this function to be suppressed so that this exception here doesn't run, and control flow kind of, I don't even know what would be returned in this case, but this would, instead of throwing a failure, this would like result in null, and then my wonderful function would turn into null or something.
Oh, it turned into failure. And the failure would
A
just
failure,
sit there
failure.
inside the map.
Right. Will be the failure of whatever was in here or something.
Right. That would be
yeah, I
really
guess-
nice to be able to switch between those. And in some cases of critical code, you want the thing to just fail. And in other cases, you want it to just leave a piece of symbolic failure in there that you can then look at.
Yeah.
I think
So-
that would be really nice.
Yeah, and I think that has merit. So let me illustrate the case I'm worried about. If I write code like this, okay, and we'll pretend this is raised and it's a failure, and I'm in this non-hair trigger mode, maybe it's the default mode in notebooks, right? Where in my code, it looks like I can never reach this case if my condition has not been satisfied. What you're describing is a way that code that very explicitly looks like, a condition has been checked and validated, and now I can do something knowing that condition is true, could still run.
I'm sorry, wait a minute. You're saying, well, yes, you're right. Yeah, that could happen. Yes.
Right. And what if that condition is, password validated, right? I mean, this is, a problem exactly like this is what caused the Heartbleed SSL bug, or Heartbleed. Sorry, it's a similar kind of, very nuanced control flow in code that at first glance looked completely reasonable.
Yeah, but okay, look, this is the whole point. We've got a slider here between the case of critical code where nothing can go wrong, just blow up if anything. If anything says boo, just exit. Versus,
for such cases, really, you have to expect that you wrap that my wonderful function with something that catches the errors and turns them into returns failure objects. I mean, that's suppress or handle.
Which cases?
Well, the ones that my wonderful function for some reason is designed to throw an exception in some cases, but then suddenly you don't want that exception to come to top level, and so you would have something like that.
No, but look, no. Look, it's more complicated than that. You have a big stack of code, and at the time when one thing was written, somebody said this is going to be a critical piece of code, but somebody else just wants to use it as a thing where if it works, great. If it doesn't, so what? And you sure don't want that lower function that said I'm critical, just exit everything, quit the kernel if I don't work.
Well, it's not quit the kernel. It's stop doing and actually throw and go up, right? And be handled by whatever handle.
Look, we keep on circling around the same problem. The problem is we can't know exactly what the programmer wants. We are automating some sort of bucketing of different kinds of things the programmer might want.
But then you use handle to catch those errors and return something useful in these cases.
In which cases?
Well, you say, okay, so this function throws an exception, but I know that this exception is not fatal in wherever I use the function, so I wrap it in handle. I say this exception turns into a failure object or $null or 0 or whatever. But I mean, you have to make your intent clear in some cases. You cannot always expect everything to just work automatically in the right way.
Okay.
Maybe there's also one other anecdote, although it's a little bit different because it doesn't really involve control flow. But this is a little bit like the third argument of quiet. And as far as I can tell, I've never seen anyone use the third argument of quiet. Yeah. I think it's much the second argument.
I have used the third argument of quiet.
Okay, but to my mind, the thing we're trying to do, there's two issues. One is it's trying to implement the sliding scale of, because there are other cases where things, one thing I've wanted to do is to have these messages that are off by default. Like, for example, there are functions which return unevaluated, and they do so without a message. But in fact, chances are, it's really hard to tell whether, I don't know, what's a good example? Whether something is an error condition. Now, there are even worse cases, like, for example, square root of -1. Okay, it could be considered an error when you get square root of -1. I mean, in a typed language, where the return type is supposed to be real, that would be an error. For us, it's not generally an error, but one can imagine one could imagine in a different setup a message that was off by default that would, message about that situation, and where that message could, if appropriate, be caught. And in other words, we've got all these things, but I don't think it's going to be the case. I mean, there are situations in which it is very well defined. Is it a bad thing? Is it not a bad thing? In the case where you can define things with types, that's an example of a class of situations in which, it's coming back with the wrong type, so it's an error. But that's not the only type of error one can imagine. Types are a particular way of essentially describing erroring or not erroring. So, I mean,
let me back up a bit. And I think what we're really talking about are conventions, right? We could have the convention that, you in your package, you handle all of your exceptions. And if, you return a failure to top level, and then if you're a user in a notebook, or if you're in a packet, if you're some third party, quote unquote, developer who's using the package, then you check for failure and re-raise the exception. Or we can have the convention that, open write doesn't throw a message and return a failure object if you try to, if opening a file fails, it throws an exception, and then it's the responsibility of the user to catch that and do what they want with it. And that allows certain kinds of programming, but it also sort of disallows other kinds of programming, like the kind where you just sort of use my wonderful function and expect it to sort of give you a list where things either succeeded or didn't.
Yeah, in other words, the programmer who uses this code, like the one who writes this map, can't write their code not being aware of which mechanism is being used reliably. And that's the problem.
Okay, look, guys, I think the thing I keep on saying is, and we need to wrap for now in a moment here, but the thing I keep on saying is, there is, one case is you're writing critical code, you want precise behavior, that's one thing.
And we're saying that you're just wrong, and that's not the question at hand.
Okay, all right, explain.
Right. Right. In both cases, it's a critical error, and the function stops working. The question is the way that my wonderful function behave, does it return a failure object, and then the caller re-raises that if they want to use that in an exception, or does it just roll with the failure object? Or does my wonderful function actually, raise an exception that moves outside of it and, allow cross package, raising and handling, which in particular would have the consequence of, that particular map, unless you wrapped it in a handle, could potentially just end in the middle without returning anything if there was an unhandled exception.
I'm sorry, I lost.
So to put it in a slightly different way, if we allow exceptions to cross the boundaries like this, we would have to somehow document that certain function that is being exposed can throw an exception. And the user who uses that in a map, for instance, they'll have to be aware of that and put handle on top of that manually. And
no, that's horrible.
Yeah, but it's hard to see whether there is a fully automated solution that avoids that.
Okay, so the issue is which functions are capable of returning a thing that you don't want any function other than handle to be confronted with something which is of the wrong structure. That is, the thing around map should assume it's going to return a list, for example, even if the contents of that list might be opaque and might contain some failure objects and things like that. But you don't want, if possible, the structure. I mean, obviously the thing that's outside the map could depend on more details about what's returned. And at some level you can't determine all of that. But you don't want it to be the case that the map might just return something completely unmap return like, so to speak.
Well, map that's well, right. That's not the case, right? If my wonderful function, catches all of its internal exceptions and returns a failure object, then you'll get a list. If my wonderful function and you don't have the handle there, if my wonderful function raises its own exceptions and that handle isn't there, then map will never finish evaluating, and it'll that exception will go on either to an outer handle or top level, and the evaluation will end. If you have a handle like this explicitly wrapping my wonderful function, then you'll get a list which will depend on the contents of what your failure function does. I guess.
But why isn't this like close confirm at this level? By the time you're this micro inside, why isn't this effectively confirm and close?
It is confirm and close.
Well, it's like in close, but
those are more than one level. Yeah.
Yeah.
Okay, it's dynamic and it goes more than one level. Is the main difference here.
Right.
Yeah.
Whereas enclosed confirm doesn't have a convenient way to do non-lexical stuff.
I mean, it does, but not in the default case.
Yeah.
I mean, two argument form does.
No, I realize.
Typical.
Right. Okay, I still want to say that, and we really need to wrap here, and we should continue this. This is a good start. I mean, I think many of the right issues are being raised, so to speak, not to make a pun. But I'm really concerned about this point about the fact that this is providing a reasonable safety net for typical programming. By the time we're kind of ratcheting it up to this is a critical path piece of code, et cetera, et cetera, et cetera, yes, the mechanism needs to work for that, but there's an awfully high value to just this generic safety net type stuff and being able to do things. Because this thing about, somebody might say, oh my gosh, you put this message, this error to do with a ill-conditioned matrix, you put it in the wrong bin. That blew me up somehow. And we're never going to be able to decide. It's like, it was hard enough. We've tried to do this, categorizing messages. Okay, what counts as a critical thing versus it might be wrong, but it isn't necessarily wrong, like square root of -1, for example. That's a very hard thing to define, and we're never going to get it precisely right.
And I don't think we're attempting to do that. Is the point?
Well, if all you're doing here is to have something which is explicit raises and handles, I don't think that's solving the bigger problem. Because the bigger problem is we've got a system where all kinds of crazy things can go wrong. And depending on what your use case is, you may or may not care about those. And what I think we need to be doing is as much as possible to automate what would, the default case is nobody's going to put in any error handling code at all. Okay. And for our built-in functions, we try hard to have good error handling. For things in the function repository, for example, we don't worry too much about error handling. But the thing is, can we make an intermediate case where there is some level of basically automated error handling that's pretty good, that maybe segues into the case where people are doing real sort of tight programming and want to make sure that nothing could possibly go wrong? Although I claim the nothing could possibly go wrong is, that's a very hard thing to define, because sometimes if you're too hair triggery, then you'll find that things where you're like, really, the thing just errored out in that case. I wanted to see the 1,000 results that I would have got without seeing the 1,001st one that errored out. I don't think one can ever completely win at that, but one can choose on the sliding scale to be more hair triggery and more kind of, if anything goes wrong, error out. Does this make sense?
Yeah. Though I think, now maybe we should try to wrap up, but I think like you were saying, it's a hard problem to do this categorization, and I'm not sure that we necessarily need to invent an error handling specific mechanism to do that. You could imagine like the case you gave, right? Like this function that's doing something internally on a matrix, and it cares about some property of that matrix. I forget exactly what you said.
Yeah.
If there are cases where sometimes you care about that and sometimes you don't, that might better be represented as an option value type thing to the function rather than something that is imposed implicitly from outside.
This is the problem. The problem is the programmer does not foresee all the things that can go wrong. Okay? And what we're trying to do is to bulk catch certain categories of things. Like, there are cases where points might be collinear. We didn't think of that. Now, is it an error case? Because then, let's say the points are collinear, so we haven't defined a normal vector direction. Okay? Is that a heinous error? Or is it just that's an awkward case, I don't know what we should do in that case? Have it come back as a pink box, and then somebody can go see, why is there a pink box there? Oh, yes, that's that case. I better deal with that case, but it's not that critical because that situation is one where we're never going to get an answer anyway, so who cares? Right? It's the programmer cannot foresee this. That's the whole point. That's the this is kind of recovery programming, not main path programming. In the main path, if they know, I should put in something that handles the case where the file is missing, great, then they know that, then they can explicitly do it. What we're trying to do, I think, is to have something where it does something not completely stupid in that case, but where if the programmer wants to put more protections in, they can go and use the same mechanism to add more protections and to be more pedantic. But if they're just doing it sloppily, the point is, even with comparatively sloppy programming, we want to be able to get the error handling to be better than it is now. That's my point of view. If they want to be pedantic, let them be pedantic. If they're not being pedantic, let it provide a decent safety net where the thing won't just go completely crazy.
Yeah. So maybe, last example, but let's suppose you have code like this. It should be written like this. If I'm being careful, I write it like this.
I presume you mean a not in front of.
Yes, right. So if I'm a careful programmer, I write this, and this is what I get. What you're talking about is I'm not a careful programmer. I'm just blindly.
Just put that in there, and then outside of that is something that asks for the string length of the result, and outside of that it does this. And you're asking for the string length, and that should fail. It shouldn't just say 17 because that's the unevaluated code answer or something. And you just don't want. This is the case. This is what I think we need to think about: is what, how to get something not completely terrible to happen, given that we're dealing with sloppy prototyping programming, or we're just dealing with very complicated code. Because the thing that, after all, a big part of our value proposition is the automation of lots of kinds of things. What we are now talking about is the automation of error conditions.
Yeah. So I want to separate between two cases, though, because I think some of the tension here is, at least for me, I don't object in theory to the idea that we could imagine some super handler that's implicitly at the outer level when you're using Notebook, and it has something like this.
Yes.
If read sync fails, I get this, right? And this I don't mind so much, because flow that just jumps away when something goes wrong, I think is defensible, like for exactly the reason you said. You want to opt into a little bit more automated error handling. What I think is more objectionable, and I think is where the tension in this discussion is coming from, is the idea instead of where we're in this case, right, where there's an explicit raise that gets kind of ignored, right? Because this, if this happens, it's kind of defined by the environment, and it's less clear that this just jumping away is going to have bad effects from code that doesn't get run. Here's code that looks like it should get run.
Well, I know.
But
so this is a question of right. So this is the question of right. This is why this is a non-trivial piece of design. By the time the user or the programmer is explicitly putting in things like raise, you probably need to take them more seriously.
Yeah.
Right. By the time, but if they're not, if they're just blindly going forward and putting in these functions, you probably want to, you just want to provide a safety net. Okay, we have got to wrap this up. There was a comment on our live stream about noting that this will affect the compiler, whatever is done here, and yes, that's completely true. Okay, we got to continue this another time. Good start, guys. Very good start. Let's